Determine the left-sided limit and the right-sided limit, and the two-sided limit as x approaches 2 of 3 over x minus 2. Each of these limits involves the limit as x approaches 2 of 3 over x minus 2. The first thing to do is try plugging a 2 in for each of the x's. That will give 3 over 2 minus 2. And 2 minus 2 is a 0, so that'll give 3 over 0. The 0 in the denominator is not actually a 0, though. This is only a limit. It never reaches the 2. And that 0 is only a small number. A limit result of a non-zero number over a 0 is a positive infinity or negative infinity. The sign of the infinity often depends on the side it approaches from, so we will have to work out the two one-sided limits separately. We have the limit as x approaches 2 from the left side, indicated by the negative superscript on the 2, and the limit as x approaches 2 from the right side, indicated by the positive superscript on the 2, of 3 over x minus 2. Let's start with the left-sided limit. The left side of 2 on the number line is something less positive than 2, like 1.99. And if we plug that in for x, we're producing something in the denominator that is a negative number, but it's approaching to 2, so it will approach to a 0, but it'll be approaching as a negative number since we're always less than 2. So we have a positive 3 over a negative 0. Positive over a negative is negative. A non-zero over a 0 is an infinity. The left-sided limit is negative infinity. The right-sided limit, we're approaching to 2 from the right side, something larger than 2, like 2.01. When plugged in for x, that will give a positive number, but it does approach to 2 and will approach to a 0. The numerator is a positive 3. Positive over positive is positive, and a non-zero over 0 is an infinity. That comes out to positive infinity. The two-sided limit depends on the results of the two one-sided limits. They do not match each other, so the two-sided limit up here will be does not exist, and there's the results of the three different limits.